Okay, question 2. A. The quadratic equation 2x squared plus 6x plus 7 is equal to 0 has roots alpha and beta. Calculate the value of 1 over alpha plus 1 over beta. So Zachary, to do this, you have to find the sum of the roots and the product of the roots first. That's the first thing you do with these types of questions. Zachary, do you know how to find the sum of the roots?
Yes, I think that's minus b over n.
Yep. So we find any sum of the roots. That'll be alpha plus beta. Now in this question, A is 2, B is 6, and C is 7. So alpha plus beta is minus B over A. In this case, B is 6 and A is 2. So the sum of the roots is gonna be what? Wait, give me a second again, I call. Yeah, let's continue. So Zachary, what is minus 6 over 2?
Negative 3. So
Great. Let's find the product of your roots now, alpha, beta. So that's gonna be what?
c over a.
Right. So
So it's
C
going
is
to be
7,
7 over 2.
right? Great. And they want us to find the value of 1 over alpha plus 1 all over beta. Just by looking at this, we can't really do anything. So maybe we should combine this into a single fraction by finding the LCM, right? Because Zachary, the only thing we know is the sum of the roots and the product of the roots. So I'll only be able to do a substitution if I see a sum and a product. That's the only thing I could do. So let's find let's find the LCM. What is the LCM, Zachary?
So that will be alpha beta.
Alpha beta. Alpha could go into alpha beta how much times?
Once.
Right? Well, is not quite, eh? It could go into beta times.
Well,
Think about it. What is it? If I had, say, 70, I could write 70 as 7 by 10, and you agree?
yes,
And what if I asked you what 70 over 10 is?
7.
Exactly. So check this. Apply the same concept over here.
Well, yeah, all right. The alpha will cancel out each other. So,
Right.
yeah.
So alpha could go into alpha beta, beta times. I know it's some weird, eh? It's some
Yeah.
weird, but it's the same concept as this. Because to get back alpha beta, when you multiply alpha by beta,
Yes.
yeah, so alpha could go into alpha beta, beta times, beta by 1 is beta. Right? Beta could go into alpha beta how much times?
Alpha times
Right? So alpha by 1 is?
alpha.
Right. Now, beta plus alpha is the exact same thing as what?
Alpha plus beta, which is negative 3.
Exactly. All over alpha beta. So, Nabil, I'm not sure if this is what you had, and you scratched it off thinking you was doing craziness, but this is the correct thing you gotta do. Nabil, let me know what went on.
Yes, sir.
Yeah, you had done this on, you had erased it.
I think so.
All right. So Nabil, are we in a position now where we can do substitution?
Yeah.
What is alpha plus beta?
Alpha, beta.
Alpha plus beta. What is alpha plus beta? What is the numerator equal to?
Um,
What did we find alpha plus beta to be?
7/2.
Now that's alpha by
Okay,
beta.
-3, sir.
What did we find alpha beta to be?
Alpha, beta is 7/2.
Great. So now we have minus 3 all over 7 over 2. So we have minus 3 divided by this fraction. So minus 3 divided by 7 over 2. So how would I turn that to multiplication? I would write minus 3 by what?
2/7.
I'd say final answer is what? What's over what?
It will be
What's minus 3 by 2?
-6.
Right? So minus 6 all over 7. That's it. You understand? If you have anything here that you do fully understand, talk to me. Let me know. And let me rectify it for you. Yeah, talk to me. Let me know what's going on. Tell me, Nabil.
Now, sir, I understand.
All right. Serena, let me know if you're hearing me now.
I see.
Okay, I hear you. Serena, long time no see.
I see.
Long time no see. Wow, long time no see. Right? Now you could actually use the calculator. Your previous calculator,
Yeah,
you could have put in fractions,
yeah, I could.
or the only thing they could not do was solve one thing.
Yeah,
Okay, all right. Well, it shouldn't be too much of a learning curve. It should be, I think the button sounding is the same, is it?
it's mostly the same.
Okay, cool. All right. Caleb, I'm not you wasn't there for the last class, so this is very new stuff for you.
Uh, um, I remember this from school. So.
Okay, so anytime you have a sum and product or roots question, you want to find alpha plus beta first, and you want to find alpha plus, you want to find the sum and the product first, right? So you're gonna find alpha plus beta, and you're gonna
Yeah.
find alpha beta.
Yes, sir.
Everything else is going to be derived from it. Now let's look at some other things you should know. Before we move on, let me tackle this question fast now, since it's right here, and we know how to do a question like this. Who wants to do this question? I'm like real fast because we're supposed to be able to do questions like this. Any volunteers? Any volunteers? Come on, Nabil, Avinash, Zachary, Caleb, Serena. Let me do this question fast. It's a light work question.
I could try it. So.
Okay, good. So Caleb, what's the first step?
Um, x plus one is yeah. X plus one equals 0.
X plus 1 is equal to 0.
Wow, what's the wrong thing?
With these types of questions, what's the first thing you do? The way I do questions similar to this in the past classes.
Can't remember.
All right. So Caleb, with these types of questions, here, let me just show you a shortcut, right? And I'll explain the long thing after. So Caleb, this is an example of a rational inequality question. So in the next line, you're going to write 2x plus 3 by x plus 1 is more than or equal to 0. And then in the next line, you're going to say 2x plus 3 is equal to 0. Then you're going to say x plus 1 is equal to 0. You're going to end up with x is equal to minus 3 over 2. And over here, you're going to end up with x is equal to negative 1. Then we're going to do a sketch of the graph. And this is the working you should put in your exam to optimize and save time. This is y, this is x, right? Caleb, in doing this, we just found the what? What do you call that for a quadratic? The what?
X value.
The roots. The roots. Those are the roots. So we're you see how we have minus 1 and minus 3 over 2? Right?
Yes.
Minus 3 over 2 is minus 1.5. So both of my x values are negative. So I'm going to put negative 1 here. And I'm going to put negative 1.5 here. Right. Do you understand why I'm putting negative 1.5 after the minus 1?
Yes, sir.
Okay, cool. Next thing, you need to figure out if the quadratic is going to be a maximum or a minimum. If I were to expand this out, what would the coefficient of the x squared term be? Talk to me, Caleb. If I expand that out, what is the coefficient of my x squared term going to be?
2
Yeah, it's going to
x.
be 2. Because 2x by x is 2x squared, so I'm going to end up
Yes.
with 2x squared. The number in front of x squared is 2.
2.
Right. That is a maximum or minimum graph.
Minimum.
That's a minimum, right? So my graph is going to look like this.
Yes, sir.
I want to figure out where my graph is what? Look at the question. I want to figure out where my graph is.
Less than or equal to 0.
Nah, that don't looking like less than.
More than or equal to 0.
Yeah, more than or equal to 0, right? If it's more than or equal to 0, positive or negative?
Positive.
Positive, right?
Yes, sir.
So should I shade inside here? Talk to me. Should I pick
Nah,
a value? Why? Why would this not work?
could I less than 0, sir?
Right, because if I take a value here, it's gonna give me less than 0. What about if I take a value on the outside?
Nah.
You sure?
Yes.
Nah, correct. Watch. If I take a value here, give me a positive or negative value for y.
Positive.
Right. If I take a value here, positive or negative?
Positive.
If I take a value here,
Positive.
right. What about if I go on this other side? Let me see.
Yeah, it'll still be positive.
Right, so my answer would be what? If I'm shading in this direction, that'll be x is what? If I'm shading those that are x values, that would be x's
Um,
less than minus 1.5 or more than minus 1.5. Talk to me. Caleb?
X is more than minus 1.5.
Nah.
No, less than minus 1.5.
If I go in that direction, that means less than. Because the value is going to get smaller and smaller and smaller. Minus 1.5, minus 2, minus 3, it's going to keep getting more negative. What if well, we know that this side is correct as well. If I shade over here, I'm going to get what?
More than minus 1.
Right. But can I include minus 1 in my answer? Let's see if you remember so. Could I include minus 1 in my solution? Look at the original thing.
Plus
Look at the denominator. What is in the denominator?
x plus 1.
Right. If x plus 1 is in the denominator, what value of x would make the function undefined? Do you remember?
X.
Do you remember when a function will be undefined?
No, sir.
Right. So somebody remind Caleb, when is a function undefined?
Oh, so when the denominator is equal 0.
Right. What value of x would make this denominator 0?
-1.
Right? -1. So you can't include -1 in the solution. So your answer is going to look like this. So you're going to say x is such that x is less than or equal to -1.5 union x is more than -1. I cannot say x is more than or equal. I can't include the equal to part because when it is equal to -1, it'll make the function undefined.
Yes, sir.
Right. Nabil, if you forgot this, be honest with me. Like, be very honest with me. I need to know if you forgot this.
No, sir.
No? Avinash, be honest with me. I need to know.
Okay.
Zachary, I know you missed a couple sessions. What did you understand or no? Is it something you feel like you could do? Or nah? Can I hear from Zachary? Serena, light work or not?
It's like work, sir.
Right. And if you wanted to include the full working, I would just parallel multiply by what on both sides. I'll put multiply by what, Serena?
X plus 1 squared.
Right. So Caleb, after today, I don't want to see you getting this question wrong, right? So look at this carefully. Anytime you have a rational inequality question, and you hear me say rational inequality, what do I mean? So rational means I could write something as a fraction, right? And this is a fraction.
Yes, sir.
And we don't like working with fractions. So to get rid of the fractions, I'm going to multiply both sides by x plus 1 squared. Well, you're probably wondering, so why am I multiplying by x plus 1 squared? Why don't I just multiply by x plus 1? And if you multiply by x plus 1, you cancel off, and I wouldn't have a fraction.
Yes, sir.
But if I do that, I get in rid of the x plus 1. The x plus 1 will completely vanish because when I multiply this side by x plus 1, 0 by anything is what?
0.
Exactly. So you can't just multiply it by x plus 1. You need to multiply it by x plus 1 squared. If I multiply it by x plus 1 squared on both sides, how much x plus 1s you have here? If it's squared, how much x plus 1s you have multiplying by itself?
2.
Alright, so 1 in the denominator will cancel off with 1 on top, and that would leave you with 1 x plus 1. So
Yes.
you have x plus 1 by 2 x plus 3. On the other side is just 0. 0 by anything is 0. Yeah, then you would find your roots. So your roots is minus 1.5 or minus 1. You do a sketch of your graph to figure out if it's a maximum or minimum. You expand this out. You saw that we got 2x squared.
Yes.
Since a is more than 0 is our minimum. And you want to see where the function is more than or equal to 0. So to do that, you're going to draw vertical lines. And you're going to look and see where it cuts the graph. Wherever it cuts the graph, you're going to then draw a horizontal line. And you're going to see if it gives you a positive value on the y-axis or a negative value. We want to get more than 0. So this is,
1.
this is, this is, this is our correct answer.
Yes.
If you take a value, if you draw a vertical line here, notice that they're cutting the graph here, and so it's
Yes.
going to give you a negative value. If you draw a vertical line here, negative value again, negative value again. So any value in between minus 1.5 and minus 1 is wrong. What if you go on the outside now and you draw a vertical line? Well, no matter what you do, you'll get a positive answer. So my answers is x is more than or equal to minus 1.5. And remind me, why couldn't I say x is more than or equal to minus 1? Why do I have to leave out the equal to?
Because it have to be more than -1.
Why can't it be -1?
Because it's supposed to be more than 0.
No, that's not why.
And
It's more than or equal to 0, right? More than or equal to 0. So it could be 0 because it's equal. more than or equal to 0. So technically, it's supposed to be equal to, but look at the original thing. What is in the denominator?
X plus 1.
Right. What value for x will make the function undefined?
-1.
Right, so we can't include -1 in my answer then. Because if x is -1, it would make the function undefined. So it has, I could only say x is more than -1. If I say x is more than or equal to -1, Caleb, that means I'm including -1 in my answer. But if x is -1, what will it do to my what will it do to my function?
It will be undefined.
It will break it. Come on, define. So you understand, I can't include -1 in my answer for that reason. I should probably make a note about that. I bet. So that's the answer for this. Right? Now we're going to move on to some other things you need to know when dealing with sum and product of roots. Let's keep marching on. So Caleb, you have plenty examples and they have videos on YouTube, right? I had posted videos on YouTube and we did a good bit of this. So you don't have an excuse. I think you have the capability and you know how to get this question correct. Don't waste it. You could do it. Right? So lock in and handle this scene. It's not that hard. It's the same procedure for all of them. Right? Literally the same procedure, which is another question. Right? This is another question. It's the exact same thing you're doing. All of them. Right? So fix up. Alright, let's move on to some other cases for sum and product of roots. Zachary, you there?
Yes, sir.
Zachary. Watch this, right? What if I give you a question and I asked you find the value of alpha squared plus beta squared? To find alpha squared plus beta squared, are you going to say alpha plus beta all squared? Is that what you're gonna do?
Sir.
Now be honest with me, Nabil. Nabil, if you get a question and they ask you to find for alpha squared plus beta squared, right? Is that the same thing as alpha plus beta all squared? Or no?
It looking the same.
Looking the same. Okay, well let me see if it's the same, right? Let me see for ourselves if it's the same. So this is the most common misconception students have. So we need to address that. Right? No, it is not the same as alpha plus beta squared. And you know that meme like with like the flower. Oh, you know what I'm talking about?
Yes, sir.
Yeah, I put it over there. Trial drawing there. I'm gonna include that sticker too. I call him Brownie for this job. Anybody own a Brownie? Anybody here have a
Yes,
Brownie? Big up, big up, big up yourself, Avinash. What's Brownie name?
Zeus, way short.
Oh, small thing. Could still,
Literally.
yeah, small thing. Literally. Oh, bumble clad. All right. So yeah, Serena, would you have had made that mistake and say alpha squared plus beta squared is the same thing as alpha plus beta all squared?
I don't think so.
Yeah,
I
sure.
would I would have put the formula of what alpha plus beta is, and then I would like square the each term. That's what I would have done instead.
Okay. I would do something similar too. I can't stress how wrong this is. This is very wrong, very, very wrong. So Nabil, you're probably saying, well, sir, why? Why is it so wrong? Why was it so wrong that I call out the dog? Let me show you why. So Nabil, let's look at what alpha plus beta all squared means, right? Alpha plus beta all squared. So Nabil, we just said that it is not alpha squared plus beta squared, right? Nabil, and we just say that is not alpha squared plus beta squared?
Yes, sir.
Well, let me see what it actually is. Question, if I asked you what is 5 squared, what would you tell me?
25.
Right, I'm gonna blow your mind here. Let's look at a logical example. So you was telling me just now, a couple seconds ago, that alpha plus beta squared is alpha plus is alpha is alpha squared plus beta squared. Now I've given you a numerical answer here, right? So like if I ask you what is 5 squared, and obviously you're gonna tell me 25.
Yes, sir.
Okay, what if I wrote 5 as 4 plus 1? Isn't that still what should the answer for that be? Still.
25.
It should still be 25, right? Now, if I using the logic you was telling me over here, right? If I using that logic, I wait to apply that same logic from here and see if it gives you 25. So if we're using that same logic, what would I write? I would say it equal to what? Hmm. Nabil, I want you to use the exact same logic you use over here. Because it's the same example, same scenario. You're so confused. Probably saying, well, what scenario? What example? Well, Nabil, over here, alpha, you said alpha plus beta all squared is alpha squared plus beta squared. So you said alpha is alpha squared plus beta squared. So what would be alpha over here, Nabil?
So I confused right now.
Okay. So I'm trying to show you why this is wrong, right? Using a numerical answer.
Yeah.
See, well, you know it wrong now, but I'm trying to show you why it's wrong. So the example I gave you was say 5 squared. What's 5 squared? 25, right?
Yeah.
Now, if I write 5 as 4 plus 1, and 4 plus 1 squared is still 25.
Yeah.
Okay, but now a way to use the logic you was using when you told me the answer was alpha squared plus beta squared. Let me show you what I mean. I want you to use the exact same logic you just told me. Use this exact same logic. I want you to compare and tell me. Using the same logic from above here. If you use the exact same logic, what should I write here?
Um, 4 squared plus 1 squared.
Right. What is 4 squared?
4 squared will be 16.
1 squared is?
1.
Is that equal to 25, which is the correct answer?
No.
No. So you understand that 4 plus 1 squared cannot be equal to 4 squared plus 1 squared.
Yes, sir.
And you understand that alpha plus beta squared cannot be equal to alpha squared plus beta squared.
Yes, sir.
That's what I was trying to show you. I was just trying to show you, like, because I know with letters and thing it'd be confusing, but if you see with numbers, it'd be like, oh, yeah, yeah, I see that making sense. Right. Let me show you how you're actually supposed to expand it now. So if I have something like 4 plus 1 squared, what that really means, it really means 4 plus 1 by what? It really means 4 plus 1 by?
4 minus 1.
No. If I have 4 plus 1 squared. Okay, and if I ask you what 5 squared is, wouldn't you tell me 5 by 5?
Yes, sir.
So if I ask you what 4 plus 1 squared is, what are you supposed to tell me? 4
4
plus
plus
1.
1 by 4 plus 1.
Right, because you are just squaring whatever is in the bracket. You have this in the bracket, so you're going to multiply it by itself. So 4 plus 1 by 4 plus 1. And the proper way to expand this now, you're going to take the first term here, and you're going to multiply by everything in the second bracket. Then you're going to do the same process for the second term in the first bracket. So I'm going to take the plus 1 and multiply by what?
4 and 1.
Exactly. So let's do what's in pink first. What is 4 plus, what's 4 by 4? 4 by 4 is?
16.
Then 4 by 1, 4 by 1 is?
4.
Right? Then we have in green now.
1 by 4 is 4. And 1 by 1 is 1.
Let's see if we're getting the 25 we're supposed to get now. What is 16 plus 4?
20.
Right, where's 4 plus 1?
5.
Right, where's 20 plus 5?
25.
Right, right. So let's apply that concept over here. The exact same concept, right? The exact same concept. Let's actually see. So let's actually see what alpha plus beta all squared is. So according to, are you going to use the exact same logic, right? What do you think alpha plus beta squared is?
Alpha plus beta by alpha plus beta.
Yeah, that is what it is. Great. Apply the exact same logic, right? Apply literally the exact same thing. So what to do next?
Factorize.
No. We want to expand the brackets. I see Caleb. I saw Caleb raise his hands. Caleb, talk to me.
You had to multiply. Now, so we'll expand it.
Exactly. So Nabil, like I said, it's the exact same process like this. You're expanding the brackets now. So Nabil, let's expand the brackets. So how am I gonna expand the brackets? Again, follow the same pattern like this. Tell me.
Alpha by alpha and alpha by beta.
Right? What next?
And then you do beta by alpha and beta by beta.
Right. And when you say factorize, when this is technically the factorized form, eh? That is the
Yeah.
fact. Because when you write it like this, you're writing it as a product of factors. Factorize means to write something as a product of its factors. Like, okay, if I had the number 40, you know how I could factorize that? If I wanted, I could write 40. I could write 4 by 10. Technically, I factorized it. Why? Because I wrote it as a product of factors. And 4 could go into 40, and 10 could go into 40.
Yeah.
Right, so this is already in the factorized form. You are undoing the factorized form to get the original thing. So that's what we're doing. We're undoing factorization. We are expanding. So tell me, what you writing in the next line?
Alpha squared
Mm-hmm.
and alpha beta. And that would be beta alpha and beta squared.
Great. Question, guys. Is alpha by beta and beta by alpha two different things? Let me hear, guys. Is alpha beta and beta alpha two different things, or are they the same thing?
The same things too.
Nabil, do you know why it's the same thing? Nah.
Yeah.
Just to make sure, and just to make sure you understand it. What if I told you alpha was 5 and I told you that beta was equal to 7? What would alpha by beta be? Wouldn't that be 5 by what? 5 by what? Alpha beta. What would that be? 5 by?
5 by 7.
What would that be?
That would be 35.
Okay. What if I asked you for beta by alpha now? Beta by alpha. How would I write that?
7 by multiplied by 5.
We're 7 by 5.
35.
Ah, so there's the exact same thing, right?
Yeah.
Because multiplication is what? That's what C. Anybody know? Multiplication is what? What is multiplication? Serena, you know? Commutative, yeah. Right. So Nabil, let's observe what we're gonna write in the next line. Oh, and this whole thing was what alpha plus beta squared is, right? So Nabil, do you understand that this is actually what alpha plus beta squared is equal to? It's not just alpha squared plus beta squared. Is actually this entire thing.
Yes, sir.
I bet. So let's look to simplify in the next line. So like what we just said that these were the exact same thing, right? So
Yeah.
you could look at beta alpha as alpha beta. So how much alpha betas you have?
2
Right, so I'm gonna write plus what?
plus 2 alpha beta.
Plus
2 beta, plus beta squared.
okay. And the original thing I had asked you to find for, I had asked you to find the value of what?
Um, Alpha squared plus beta squared.
Right. And Nabil, the only thing we know is the sum of the roots and the product of the roots. Like this is literally the only two things we know. We only know what alpha plus beta is and alpha beta. Anything else, we're in trouble. That's the only thing we know. So Nabil, for me to do any type of substitution, whatever I get, it needs to have alpha plus beta in it. So I could say I could do a substitution, and it needs to have alpha beta in it. So I could do a substitution. So keep that in mind, right? Keep that in mind. Keep that in mind for me.
Yeah.
So from the start, we wanted to find alpha squared plus beta squared. That's what we wanted to find. Just to remind you, we wanted to find alpha squared plus beta squared. When you look at this, are you seeing an alpha squared anywhere and a beta squared anywhere?
Yeah.
On what side?
On the left, the right side.
The right. I see an alpha squared here, and I see a beta squared here, and you see that.
Yeah.
So if I wanted to make alpha squared plus beta squared the subject of the formula, what should I move across then?
The 2 alpha beta.
Yeah, what you do nobody? What you do nobody? Right? 2 alpha beta want to be in everybody fit. Right? Relax yourself, alpha beta. Relax yourself. So we're gonna move that across. So Nabil, if I move across 2 alpha beta, what is it gonna look like on the left hand side?
Um, Alpha plus beta squared
Mm-hmm.
minus 2 alpha beta is equal to alpha squared plus beta squared.
Ah, talk to me now. Talk to me now, Nabil. Do we know what alpha squared plus beta squared is in terms of the sum of the roots and your product of the roots?
Yeah.
Yeah, Nabil, would I be able to do a substitution over here?
Um,
Do we have any formulas for alpha plus beta? Is that something we could find?
Yeah.
How would I find alpha plus beta? What is the formula for that?
Um,
And if you forget, check back your notes or you could ask your fellow classmates. See if they could assist. What's the formula for alpha plus beta?
mm,
I see Caleb really excited. Caleb raise his hand. You want Caleb to take it or you want to figure it
yeah.
out? No, but like you see, Nabil, it in the working you sent me. It in the working you sent me. How did you find alpha plus beta?
Is it 1 over?
Nah, it's not 1 over. It's in the working for the homework question. It's in the working. How did you find alpha plus beta by using what formula?
AX squared.
Nah. Again it's third line. It should see alpha plus beta is equal to something. Oh wait, I looking at Serena working. My bad. Nabil. Yeah, it's in your working, eh? You have A plus B. It really supposed to be alpha. Okay,
Um,
all right. So we have some work to do, right, Nabil? We have some work to do. But that's okay. We'll get it done and we'll understand it. Right?
yeah.
But the only thing I have to tell you is after today, make sure you have it locked in. Because if you learn it today, I do expect in the next class that you forget again. Right? I will take as much time as I need to now to make sure I understand, but I can't keep doing it every class. So after today, have it locked in. Right? And if you're confused outside of class, feel free to message me. I could do all Zoom if I had time. But make sure you understand it today. Right? So Caleb, talk to me. What is alpha plus beta equal to?
Minus B over A.
Right? So Nabil, look at you working. Tell me if you had that anywhere.
Yes, sir.
Yeah, you did. Right? So remember that this is the formula for alpha plus beta. So Nabil, given a quadratic, if I'm given a quadratic, I could actually find what alpha plus beta is. So that's not a problem. I could actually find a value for that and then replace it. Okay, do you know what the formula for alpha beta is? Talk to me, Nabil.
Um, C over A.
Right, it's C over E. So did we accomplish our goal of finding what alpha squared plus beta squared is in terms of the sum and the product of the roots?
Yes, sir.
Right. So, long story short, anytime you see alpha squared plus beta squared, what are you going to replace that with? Instead of writing alpha squared plus beta squared, what are you going to write? What is alpha squared plus beta squared also equal to?
Alpha plus beta squared minus 2 alpha beta.
Yep, that is it. Guys, do we understand how to derive alpha squared plus beta squared if you forget?
Yes, sir.
Okay. Serena, do you have any problems or are you good?
I'm grateful.
All right. Cool. Zachary, let me know what is going on.
Like it.
Okay, great. Great. So I'll give you all some time to copy this down, and I'm going to give you all a past paper question, and I want to see how you all can handle that. So Zachary, do you think you understood why I wanted to write it in terms of alpha plus beta and alpha beta? Or nah?
Yes.
Right? Because Zachary, try to explain why. Why would I want to write it in terms of alpha plus beta and alpha beta. What is so good about that? Why would I want to do that?
Come back again when you sell other stuff.
Say that again?
Those two things come up again when you're working out other sums in the equation.
Yeah, but the main reason is we need to write it like that because we can actually find for alpha plus beta and alpha beta. Understand what I mean, right, Zachary? Like if you want, you could get a numerical answer for alpha plus beta. Like you know how to find alpha plus beta.
Well, yes,
Everything else is going to be derived from alpha plus beta and alpha beta. So you actually know what alpha plus beta is, and you actually know what alpha beta is. There are formulas for them. So if I want, I need to write everything in terms of alpha plus beta and alpha beta. That's what I need to do. Great. So make sure you have this copy down. And if you don't take away anything from this, just please take away this. This is the important thing that I needed to take away, at least. This is very important. Because in the exam, they don't expect you to do the whole derivation and thing. They just want to see you know what alpha squared plus beta squared could be represented as. Right, so have that copy down. Serena, if I wanted to find alpha cube plus beta cube, you think you'd be able to figure that out?
I think so, but it might take me some time.
And it would take me some time as well. It would. Because Serena, in that instance, you would have to you'd have to do you'd have to multiply it by itself 3 times. That would be a very tricky binomial expansion.
Listen,
Yeah. What if I told you there was a trick though? There's like a pattern people notice at some point. Like when you do pure maths in upper six, there's this thing called binomial expansion, and you'll expand on binomial expansion. You'll learn about Pascal's triangle and how to generate how to like you'll be mind blown. It makes it so easy to expand. Like if I want, I could use that to find alpha to the power 7 plus beta to the power 7. And I know how to like I tell you, cool. I don't even have to I could just start from a side. I don't have to, multiply it by itself 7 times. It's really cool.
it sounds so.
Yeah. Right, but just for your knowledge, let me show you what alpha cube plus beta cube is in case it comes. See second as sus. Right, so if you need to figure out alpha cube plus beta cube for whatever strange reason, this is what you're gonna do. That is going to be equal to, so Nabil is not A, it's alpha, alpha, alpha. And it's not B, it's beta. Right, so alpha
Yep.
cube plus beta cube will be alpha plus beta by Is there any easy way to write this? It would be alpha squared. Yeah, so you could learn that off. And well, Serena, you see how you have a squared minus b alpha squared minus beta squared? What's it? Alpha squared plus beta squared. You see how you have that there?
Yes, sir.
You would have to recall this. I know it's like real looking for cubic.
Oh,
It's like real
yeah.
looking. Mm-hmm. Right, let me give all y'all the assist. There's an easier way to do it. There's another identity you could use. Thank God. Alpha plus beta cubed minus 3 alpha beta alpha plus beta. I think that looks easier to memorize. Yeah. Yeah, guys, so copy that down for me, please. And then we should be good. Should be very good. Yeah, so as soon as you have this copy down, please tell me.
Finish, sir.
Right. Avinash, what about you? Avinash, Zachary, Nabil, Serena. Are you good, Amon, right?
I will see.
Everybody finish it?
Yes, sir.
Okay, cool. Time for me to give you all questions. Let's go. Are you all excited for the questioning? uh, how are we looking forward to the questioning? No, 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 no. No.
Yes, yes, sir.
Right, great. Good luck. That's all I will say. Good luck. Yeah, I will say that. So B part one. The quadratic equation 2x squared plus 6x plus 7 is equal to 0 has roots alpha and beta. Determine the equation with integer coefficients that has roots alpha squared plus 1 and beta squared plus 1. Okay, so I'm just giving us some guidelines, right? So, Nabil, you there?
Yes, sir.
Alright, so Nabil, the very first thing you should do, you should find the regular sum of the roots and the regular product of the roots. That's what you should do. Have that line around because that is what you're going to use to figure out everything else. Everything else is going to be derived from that, right?
Okay, sir.
Right. So Nabil, in this case though, we want to determine a new equation with what coefficients? The same alpha plus beta root or different roots?
The same alpha plus beta?
Nah, different roots. So remember, alpha and beta are the roots for the original quadratic. But in this question, they want us to figure out the equation of the new quadratic if it has different roots. What are the different roots here, Nabil? Look at the question. What are the different roots? Instead of alpha, what you have? Instead of the root being alpha, what you have for that? What is replacing alpha?
A squared?
Alpha squared plus 1. That's alpha. And
Yeah.
what is replacing beta?
Beta squared plus 1?
Right. So what would the new sum look like? The new sum. So if alpha and beta are the roots, then to add them, I'll just simply say alpha plus beta. If these are my two new roots, how would I write that as a sum?
It will be A squared plus 1 plus B squared plus 1.
Right. Again, get in the habit of saying alpha and beta. Right. So alpha squared plus 1 plus beta squared plus 1.
Yes, sir.
This could simplify to alpha squared plus beta squared plus what?
2?
Right. Do we know what alpha squared plus beta squared is?
No.
Yeah, we do. That was the last thing we do just now.
Oh,
What is
yeah.
alpha squared plus beta squared equal to?
Um,
See, Caleb raise your hand. Caleb real excited, boy. Wait,
F
let me let Nabil try to figure it out first, and then you can ask
alpha,
us. Yeah, talk to me.
alpha plus beta squared
Mhm.
minus 2 alpha beta.
Yep, that is correct. Caleb, you was going to say that?
Yes, sir.
Okay, good. So guys, with these type of questions, you want to find the original sum and the product. Then you need to find the new sum and the new what? The new sum and the new what? So remember, a quadratic has a sum and a what? A sum and
Product.
a product. So Nabil, how would I find the new product? So how would I find the new product of the roots?
I don't know, sir.
Now you could figure this out. You could figure this out for sure. So Nabil, if I say product are roots, right? What are my new roots? Come on, Nabil. When you read the question, what are the new roots?
Alpha squared plus 1,
Mm-hmm.
beta squared plus 1,
Right, and we want to find the product. So how would I write? What does product mean?
multiply,
Right. This is one of the new roots, and this is the other new root. So it's gonna be alpha squared plus 1. Yeah, what next?
multiply by beta squared plus 1.
Right, and you know how to expand that?
Yes, sir.
Right. It's the exact same procedure as like the last steps. Like this by that, this by that. And from there, you will need to see if you could write it in terms of alpha plus beta or alpha beta. And then you could substitute. Finally, do you all remember how you would recreate a quadratic? Serena, remind me. Do you remember how to recreate a quadratic if you have the sum and product?
Yes, sir.
Talk to me.
Um,
Right? Tell me.
it would be x squared minus the sum of the roots x.
right? Plus,
Plus the product of variance.
and our entire thing gonna be equal to what?
0.
Now they said they want integer coefficients. If it's an integer, then it could be a negative number or a positive number, including 0. But it has to be a whole number, like -1, 0, 1, -5, 5. Understand?
Yes, sir.
So integers are whole numbers, including 0 and negative numbers. So fix up. Give it a try. I'm giving you all. Serena, how much time you think you need?
I'm not sure, honestly.
Give me like an estimate.
Um, 6 minutes.
6 minutes? Here, I'll give you 7 since it's 7 max.
Mhm.
Good luck, guys. Nabil, please give it a chance. Please give it a try, right? Avinash. I didn't hear from you in a while, Avinash. Talk to me. What's going on?
At this, at figuring it out so far.
Alright, so Avinash, I want you to tell me the basic rundown for this question. Like, what is the first thing you have to do?
Well, basically, you gotta get the. Okay, so using two of my tongue aside. You gotta get the original thing for alpha and beta.
Right? Get the original one. Mm-hmm.
Then you have to. It was on top of my tongue. It's also.
Say that again.
Um, then the roots.
So you had to find the original sum and product of the roots. Then you're gonna find
Yes,
then you're gonna find the new what?
new sum and product.
Right. Once you have the new sum and product, then you're gonna do what to recreate. What would you do next to recreate the quadratic equation?
The x2 minus sum of the root.
Yeah. X squared minus sum of roots x plus product of roots.
I have to go now.
Okay, Zachary. Thank you for coming. Please try to do the extra questions or the homework in the notes that's in the chat and try it.
Yes, sir.
Otherwise, it's a fall behind. Right?
Yes, sir.
Have a good evening.
All right.
Later.
Yeah, you too, sir.
Okay, the time is up. Serena, let me know what's going on. I kind of hearing you, not completely. Yeah, you think you're a bit confused, but you're gonna sum what we have so far. Okay, cool. Caleb, Avinash, what going on, guys?
I don't really know to do this.
This one a bit tricky.
Yes.
Yes, sir.
Serena, that's supposed to be alpha plus beta, and not alpha squared plus beta squared.
Which part, sir?
So for the second line, I think you're supposed to write alpha plus beta.
Oh,
You have alpha squared
yes.
plus beta squared, right? So we have here. So that'll be alpha squared plus beta squared, which is alpha plus beta, which is minus 3 squared. Minus 2 alpha beta, which is going to be minus 7. Seems to be correct. Oh, wait, Serena, talk to me.
Yes, sir.
I see that in the second line, that positive 2 turned to a negative 2. You see what I'm saying?
Yes, sir.
Yeah. Gotta be moving carefully. Alright. Caleb, let me know what's going on your end. At least on my picture what you have so far, so I can see what's going on. Avinash, same thing. Yeah?
But phone not higher number that right now, so I can send a picture.
Okay, well, walk me through what you did so far and tell me what you got so far.
But I get the alpha plus beta and the alpha beta
What did you get for alpha plus beta?
-6 over 2. Well, -3.
Right? We get for alpha beta.
7, well, 7 over 2, yes.
And how did you find the new sum of the roots?
A squared plus 1 plus B squared plus 1.
Again, alpha plus beta, right? Alpha plus beta.
Yes.
And what you say next?
Well, that what I have.
Alright, so Caleb, now I need to ask you if you could simplify. You see you have plus 1 plus 1?
Yes. And that alpha squared plus beta squared plus 2.
Right. Now, do we know what alpha squared plus beta squared could be written as? That's the next question I have
Alpha
for you.
plus beta squared.
Yeah. Alpha squared plus beta squared. Is there any way, and is there any other way I could write that so I could actually substitute alpha plus beta and alpha beta?
Um, Alpha plus beta squared minus 2 alpha beta.
Right. So that is what alpha squared plus beta squared is. So you're supposed to write that down, right? So you replace alpha squared plus beta squared with that. Because that is why we ran through this, right? Anyway,
Yes.
you see alpha squared plus beta squared, don't leave it. Replace it with alpha plus beta squared minus 2 alpha beta, right? And then you'd be able to plug in what you found originally. So I hope you have it now. So continue.
Yes.
So that's how far I'll get up that. Think I'm going correct?
Let's see. You're not wrong, but now you have to utilize what you find. So Avinash, when you find any sum, you know how to put in brackets, yeah? You don't have to put these sum in brackets. You put in brackets when you want to multiply.
Oh, okay. Okay, sir.
Right? But I like what you did though, Avinash. I like what you did. So guys, what Avinash did, right? He actually found what alpha squared plus beta squared was from the start. So he found out alpha squared plus beta squared was 2. So anywhere that he sees it in the future, he just has to write 2. Instead of Serena, you hear what you do? He actually calculated for alpha squared plus beta squared at the start. So now he has a numerical value for it. Right? So Avinash, you have to find a new sum, right? To find a new sum, you have alpha squared plus 1 plus beta squared plus 1. Are you seeing any like terms there?
It's 1,
Right, 1 on 1. If you add 1 on 1, okay.
2.
Right? So what is your next line gonna look like? After you simplify, what is your next line going to look like?
Alpha square plus beta squared plus 2. Well, since I added 2, it'll be 2 plus 2, I guess.
Exactly. That's it, That is it. That is it. Yeah. That's easier than you think, It's easier than you think. So continue.
Okay.
All right. So Caleb, did you make any progress with these so many roots? Caleb, did you make any progress with regards to the so many roots? Caleb, you there? Um, Serena, were you able to get these so many roots and use so many roots? Serena, let me know if you're hearing me.
What do you mean, sir?
Yes, know what I mean?
Yes, sir.
All right, so the original roots for the question is alpha and beta. Alpha and beta are the original roots. But we want to figure out the new quadratic with different roots. So the new roots are alpha squared plus 1 instead of alpha, and instead of beta, it's beta squared plus 1. So the new sum of the roots is alpha squared plus 1 plus beta squared plus 1. What was your final answer for the new sum of the roots?
4.
4, that's correct. So now you have to find the new product of the roots. How do you find the new product of the roots?
Um,
Is
I'm not
easy
sure.
is easier than you think. So Serena, what are the new roots? Serena, what are
4,
the nah? What are the new
no.
roots?
Oh, A squared. I mean alpha squared plus 1 and B squared. I mean beta squared plus 1.
Correct. So if I want to figure out the product of the roots, I just have to find that product. So how would I find the product of that? Talk to Miss Serena. How would I do that?
Squared plus 1.
Say that again?
You would multiply alpha squared plus 1 by beta squared plus 1.
Yeah, that's it. That's it.
Oh, okay, thank you.
No problem. And then you look to see if it have alpha plus beta or alpha beta, so you could do a substitution. Right. So Caleb, you making any progress? Talk to me, Caleb. Can I hear in Caleb? Avinash, making any progress?
My bad, sir. I had to go outside to collect some.
Okay. You make any progress yet? Talk to me. Let me know if you got the new summary roots.
I get -9, take away 7, sir. All right.
-9, take away 7.
But
Nah,
A squared plus B squared.
nah, something wrong there. It's supposed to be 9 minus 7.
Yes, sir.
Check that again. All right, so I'll assist. I see like I want Ollie to be able to get a question correct by all yourself, eh? I don't want to be helping Ollie every minute. And that's all they get any question correct. I want Ollie to actually be able to get a question correct on their own. So I'm not gonna help. I'm not gonna give Ollie the answer on the screen. I want you all to come up with it. So Caleb, send me a picture of what you have so far. Let me see what you have so far.
So remember, I can send you a picture, sir.
Okay, well, tell me what you have in writing.
After, well, A squared plus B squared equals A plus B squared minus 2AB. And now
Mhm.
it's -3 squared
Right? What is -3 squared? Remember,
-9.
no. Mm-mm. Be very careful. -3 squared means -3 by.
-3.
Where's -3 by -3?
9, positive 9.
That was a mistake, right?
Yes,
So you're supposed to write that in brackets. You're supposed to write -3 in brackets squared.
yes, sir.
Yeah. Right, so keep going. Serena, are you getting through?
I don't think so, sir.
You don't think so?
Mm-mm.
Some more picture we have so far.
Okay.
So Serena, you know you have it, right? You know, like you're extremely close to the answer. I promise, Serena, like you could almost taste the answer, you know. Parts of that you already know the answer for. So you have alpha squared, beta squared, plus alpha squared plus beta squared plus 1. Which part of that could you easily solve for?
The alpha squared plus beta squared.
Great. So the only issue is the alpha squared, beta squared. Both of these are being raised to what power?
2.
So if I want, is it possible for me to write alpha beta all squared?
Yes, sir.
Is that something we can solve?
Oh, yes, sir.
Yeah, you can handle that.
Thank you, sir.
No problem.
So that's the same spot I was stuck on.
Yeah, watch. Alpha squared beta squared is the same thing as alpha beta all squared because you're squaring both of them. Mm-hmm.
So that's the same part I was stuck on just now.
It look complicated, but it's simple. But I understand. You all are learning this for the first time, man. I understand. I understand. So I'm waiting for an answer. I want to see you all get an answer. Right, Caleb? Are you getting through the product of the roots?
Yes, sir.
Okay. I haven't heard from Nabil in a very long time. Nabil, tell me what's going on. Can't hear it from Nabil at all. And so I'm waiting, guys. I know you all could do it. It's possible.
So you can just check this piece, man. I'll send you a picture
Okay, let me see.
on it.
Let me see what's going on. Tamid?
Yes, I got it.
Let me see what's going on. So for the product, right. Great. Great. That looks correct. Yeah, that's correct. And now you could just plug everything in and solve. You know what to do next. Continue. And you know what alpha squared plus beta squared is? Avinash?
Then I just
You found it earlier, you know.
and I just see two.
Yeah, that's just C2. All right, Serena, let me see what you do. All right, so Serena, I would recommend that you leave your answer as an improper fraction, right? Yeah. And how did you get 4 for alpha squared plus beta squared? It wouldn't be 4. Alpha squared plus beta squared wouldn't be 4. Now, Serena, I see for alpha squared plus beta squared, you replace that with 4, but that wouldn't be correct. Do you know why?
Because, oh, because I thought to.
So that again?
Wait, I'm not sure actually.
Okay, that 4 is for alpha squared plus 1 plus beta squared plus 1. That is not for alpha squared plus beta squared. If you understand what I mean.
Oh,
You found for
yes, sir.
that 4 is alpha squared plus beta squared plus 2. So what would alpha squared plus beta squared be?
2.
Yeah, 2.
Okay.
Okay. Avinash, I think you should be very close on answer.
So for a fraction, I get 61/4. Okay, so.
I'm telling you that's correct.
Oh, yeah, me.
Let me see. No, let me see if it's correct.
Okay.
Yeah, that's correct. 61/4. So now, Avinash, what you need to do is you need to combine everything. And you need to make sure your answer is written as where all of the coefficients are integers, not fractions. So
Okay, okay.
Avinash, put everything into the form now, and it should be good.
Yes, sir.
Caleb, what is going on your end?
I get the A squared plus B squared.
Okay.
And I lost after that. Sir.
All right, so Caleb, you do the question, all right?
Yes, sir.
Okay. Avinash and Serena, it seems like you all got it. Serena, what line are you on right now?
I finished it. I got the same thing as Avinash.
Nice. Good job.
Mhm.
But I need to write my answer. I need to determine the equation, right? But it must have integer coefficients. So the coefficients cannot be fractions. So how would I write this thing such that all of my coefficients are whole numbers? Okay, so Avinash and Serena, when you're done, please send your answer in the chat. Okay, so Serena, that's not entirely correct. So I want you to leave your answer as a fraction and I want you to ask yourself, okay, if you convert it to a decimal, Serena, that doesn't help your problem because it's 15.25 an integer.
Yes, sir.
No, so you'd have to do something throughout to get rid of the denominator. What would you have to do throughout to get rid of your denominator?
Mm, multiply by 4.
Yes, so I'll have to multiply by 4 throughout.
Okay.
And that would give me integer coefficients. Okay, guys. Avinash and Serena, still may have any chat. Nabil, did you come back?
Yes, sir.
Okay. That it was out for a while. Is everything all right?
Yes, sir.
Are you sure?
Yes, sir.
Okay.
I came back like 5 minutes ago.
All right. Avinash and Serena, let me know what's going on. I would like you guys to send your answer in the chat.
We sent it already, sir.
Sent it? You multiplied everything by
Yes,
4?
sir. Yes, sir.
I bet. Oh, talking about in the group chat, huh?
Oh, okay.
Sent it, sir.
Nice. So try to send your full working.
Yes, sir.
So Caleb and Nabil, you guys will be helping me with this question. Right, so Caleb, let's start, right? Caleb, you there?
Yes, sir.
Right. So Caleb, the first order of business, we need to find the original sum of the roots and the original product of the roots. So to do that, it's going to be alpha plus beta. What am I finding for here, Caleb? I'm finding for the what?
The originals.
Right. This is the sum of the roots,
Yes.
where alpha is one root and beta is the other root. And to find the sum of the roots, it's going to be minus b all over a. Tell me what
Yes.
to do next, Nabil. Nabil, talk to me. What to do next? Nabil,
Yes, sir.
what to do next?
Um,
Do you know what to do next? Talk to me.
Put the numbers in the equation.
Yep. What is B and what is E?
B is 6
And A is?
and A is 2
So the sum of the roots is?
minus 3.
Great. What is the other thing we need to find?
The product of the root.
Yep, we need to find the product of your roots. So alpha is one root and beta is the other root. So we're going to write alpha by beta. And this is the product of the roots. And that is going to be equal to what over what?
Um, C over A.
Yeah, C over A, right? What is C and what is E?
C is 7 and A is 2.
Right. Great. So guys, what we have here is the original sum and the original product. But we want to figure out the new equation with different roots. What are the new roots now? What are the other roots? What are the new roots? Nabil, when you read this question, what are the new roots?
Oh, sorry, sir. The roots is alpha square plus 1 and beta square plus 1.
Right. So the new roots are alpha squared plus 1. That's one root. And the other root is beta squared plus 1.
Yes, sir.
Now, something that Avinash did to make his life simple, he calculated one time? He actually calculated alpha squared plus beta squared one time. So let's calculate that one time. Does everybody know what alpha squared plus beta squared is actually equal to?
Yes, sir.
What is alpha squared plus beta squared equal to?
Alpha plus beta squared minus 2 alpha beta.
Right? Alpha plus beta all squared. Right?
Minus 2 alpha beta.
Do I know what alpha plus beta squared is? And do I know what alpha beta is?
Yes, sir.
Right. Nabil, can you tell me what alpha plus beta is?
Alpha plus beta squared.
Now, what is alpha plus beta? We already found that. What is alpha plus beta?
That is a minus 3.
Right, minus 3. Right? Minus 2 alpha by beta. What is alpha beta?
7 over 2.
7 over 2, right? So minus 2 by 7 over 2. You're probably wondering, well, why would I go and find alpha squared plus beta squared? The reason I'm doing this is because I'm seeing that my new roots have alpha squared and beta squared in them. So maybe somewhere you might see alpha squared plus beta squared. So it makes sense how we find for that one time. Right? So Nabil, remember alpha squared plus beta squared can be written as alpha plus beta all squared minus 2 alpha beta. Before you do anything, you need to find alpha plus beta, and you need to find alpha beta. So we did that at the start. So we have that at the start, right, Nabil? So now it's just a matter of substitution. So Caleb, tell me what I would write in the next line. What is minus 3 squared?
9
Right? What is minus 2 by 7 over 2?
minus 7.
Right? Because the 2's will cancel off, right? So just be minus
Yeah.
7.
Yes.
What is 9 minus 7?
2.
Great. That being said, let us now figure out what the new sum is and the new product is going to be. Right. So, Caleb, my new roots are alpha squared plus 1 and beta squared plus 1. So,
Yes.
my new sum is going to be what? What is my new sum going to be? New sum of roots.
A squared plus 1 plus B squared plus 1.
Are you seeing any like terms over there?
Yes, sir. So A squared plus B squared plus 2.
Right. Alpha squared plus beta squared plus 2. Because you are 1 on 1 combined to give you 2. Now, notice that you're seeing alpha squared plus beta squared. Right? You're seeing alpha squared plus beta squared. What do we know alpha squared plus beta squared is equal to?
2.
Just calculate it already. Calculate it already, so it's 2. So that's just going to be 2 plus 2. So the new sum of the roots is 4. Understand?
Yes, sir.
Okay. Now, Nabil, you there?
Yes, sir.
Nabil, if you did not calculate this in this line, so forget about this. If you didn't calculate it, forget about it, right? What would you write in the next line? What would you replace alpha squared plus beta squared with?
Um,
Nabil, remind me, what is alpha squared plus beta squared equal to?
Alpha plus beta squared minus 2 alpha beta.
Right, so if you didn't do it at the start, this is what you would have to write in the next line. You would replace alpha squared plus beta squared with this, then you would plug in everything and you would solve. Great. But since we calculated at the top, it's already there for us. We know that alpha squared plus beta squared is just simply 2. So we replace it with 2. Let me know if you're confused.
No, sir.
You sure?
Yes, sir.
Okay. Well, Nabil helped me with the other one time. So I found the new sum of the roots. Now we need to find the new what?
Product.
Right, we need to find a new product of roots. So how am I going to do that?
That would be alpha squared plus 1 multiplied by beta squared plus 1.
Say that again?
Alpha squared plus 1 multiplied by beta squared plus 1.
Right. How am I going to expand this?
But it will be alpha squared multiplied by beta squared and alpha squared multiplied by 1
What
and
next?
1 by beta squared and 1 by 1.
Right. So let's do the green part first. So alpha squared, beta squared is just alpha squared, beta squared. Then we have alpha squared by 1, which is just plus what?
Plus alpha squared,
Right? And then we have 1 by beta squared.
which is plus beta squared
Mm-hmm.
and plus 1.
Okay. Now, Nabil, notice that everything here is being squared. So instead of writing alpha squared, beta squared, I could actually write this. I could say alpha beta in brackets squared. Right? Talk to me. Over here, you're seeing what?
Alpha squared, beta squared.
Yeah. And earlier, we found what alpha squared plus beta squared was. And it was what?
It was alpha plus beta squared minus 2 alpha beta.
Right? And we calculated it to be what?
4.
Nah, that was the sum of the roots.
2.
2, that's what alpha squared plus beta squared was. This is not, I repeat, this is not alpha squared plus beta squared. This is alpha squared plus beta squared plus 2. That's what that is. That is not alpha squared plus beta squared. Alpha squared plus beta squared is just simply 2. So you see this part over here? I'm just going to replace that with what?
2.
Right, with 2. Right, plus 1. And alpha beta. Do I know what alpha beta is?
Yeah, 7/2.
Right, 7/2. So we are going to write 7/2 squared plus 2 plus 1 is 3. What is 7/2 squared?
Twelve and a quarter.
I want you to tell me the answer as an improper fraction, if possible. You have a Casio or a Sharp?
Sharp.
You have a Sharp. I'm not sure how to get it as a... Wait, I'm gonna look up a Sharp calculator real quick. Which area are you from by chance?
Barpo.
Next time you're in San Fernando, look for LF Trading Center and go and buy the Quest 2 calculator. Is the same thing as a Casio. It's a knockoff Casio, but it's $105. It's really cheap. It's really good.
My
Yeah.
sister might have a Casio.
Well, get the Casio. Don't continue using that Sharp.
Well, my math teacher just tell me Sharp better than Casio.
No. Something wrong with them. Something wrong with them. They want to see you have a hard life. That's why. The things you could do with a Casio, eh? You could solve equations and thing on a Casio.
Mhm.
Right? Caleb, talk to me. I see you have your hand up.
49/4.
Yeah, it could be 49. Well, 7/2 squared, it would be 49/4, right? Because 7 squared is 49 and 2 squared is 4, right? Plus 3. Now, if I wanted to write 3 a some number over 4, tell me what over 4 would give me back 3? What over 4 would give me back 3? Tell me, Caleb.
12.
Yeah, 12/4 would give me back 3. Now, since I have the same denominator, I could just add. So 49 plus 12 is 61. So that's going
Yeah.
to be 61/4. So guys, now I have my new sum and my new product of my roots. Is everybody okay with that? Or not? Caleb, you confused or you understand?
I understand.
All right. Great. So now we need to form the equation. So if I have the sum and the product of the roots, how could I figure out the equation? Somebody tell me. How do I get the equation using the sum and product of the roots?
X squared minus the sum of the roots by the product of the roots
Nah,
equals 0.
minus sum of roots by x plus the product of roots equals 0. And we need to write our answer with integer coefficients. Do you all know what an integer is? Do you all know what an integer is? Or nah? Nabil and Caleb, do you all know what an integer is?
I can't remember what it says.
All right, so an integer is everything other than a fraction. So ones is not a fraction. So no,
Right.
no fractions. No fractions. So an integer, an example would be all whole negative numbers. So like -1, -3, -7, etc., etc. It would include 0 as well, and it would include all positive whole numbers. Right? You'll see why I'm saying that. So Nabil, if I want to form, because if you're confused, look at what the question said. The question said, determine the equation with integer coefficients which has new roots. So we figured out the sum of the new roots, and we figured out the new product of the roots. And if I want to form the equation, I'm going to use this. X squared minus sum of roots by x plus the product of the roots. So Nabil, what is the new sum of the roots?
4.
Yeah, so I'm going to write minus. So you see the sum of the roots bracket there, I'm going to replace that with 4, so x squared minus 4x. And what is the product of the roots?
It will be plus 61 over 4.
Right, but remember, we want integer coefficients, meaning that our numbers, it must not have any fractions. Well, right now we have a fraction. We have 61 being divided by 4. What would I need to do to get rid of that fraction?
Divide by 4 on each side.
Nah. If you divide by 4, you're going to cause a problem because now you're going to end up with x squared over 4, 4x over 4, and then 61 over 4 over 4, which will be 61 over 16.
Yeah.
Ah. So if I want to get rid of the 4, right now 61 is being divided by 4. What is the opposite of dividing by 4?
Multiply.
I'd say multiply both sides by 4. Think about it, right? 61 over 4 multiplied by 4. The 4s are going to cancel off. So it's just 61. You okay?
Yeah.
So talk to me right, Nabil. If I multiply everything by 4, what am I going to get?
4x squared minus 16x plus 61 equals 0.
Yep. And that is the answer. Yeah. That is the answer. Caleb, be okay with this now?
Yes, sir.
I bet. Nabil, I feel like it are some things you're still not entirely sure about. I could sense it in your voice.
I understand it.
Okay. The best way to see that is for you to do questions. So I'll give all you some homework. But let me give all you the general rundown, right? With these type of questions, the first thing you need to do is find the original sum and the original product. Everything else is going to be derived from that. And anytime you see it had new roots and it have like squared up or here this, anytime you have new roots and you see a squared in it, my advice is you should probably find for alpha squared plus beta squared at the start. Because Serena, you saw that it's how easy that made life, right? By me finding what alpha squared plus beta squared was, I just had to plug in 2 everywhere I see alpha squared plus beta squared. You know?
Yes, sir.
I didn't have to write alpha plus beta squared minus 2 alpha beta every single time. So that definitely made our job easier. So once you have a new sum and a new product, all you have to do is plug it into this, And if you want to get rid of the fraction, just multiply by the number in the denominator. Question, guys. If I have, like, let's just say it was minus 4x all over 3. What would I have to multiply by instead to get rid of all of the fractions? Does anybody know?
Well,
Right, you'd have to multiply by 12 because 12 is the lowest common multiple between 3 and 4. Meaning that 3 could go into 12 and 4 could go into 12 to give you a whole number. Great. So let me give you all homework one time. Next class, moving on to coordinate geometry. Guys, I did complete any square with you all, yeah? Oh, you remember that?
Yes, sir.
Alright, cool. Right, so I want you all to do 2017 question 2A. Right? Oh no, we did that. You all did that already. We did that already. Never mind. That's easy. Right? This question here. So you all could take. Let me just take a screenshot of this. Well, could just copy it. Copy. So this is all your homework. Not just this question. You'll have more. Cause I feel like this is such easy marks to get. I would hate to see you all lose these marks. Right? Mm. Caleb and Nabil.
Yes, sir.
I'm also throwing in this question for you guys because I feel like you all aren't as proficient as I'd like it to be. I want you all to certainly get these marks, so take that question for homework too. Um, this is a lovely question. Oh, I love this one. I love this one. It's a lovely question to give you guys. Do this whole question. This would test you all in quadratics pretty good, right? I probably like rage quitting, like, damn, this man giving me real homework, boy. That's crazy. Yeah. It sounds so wheezy what I'm looking for. Like, well, are they actually going through this in all in like right now? And all the teachers go be like, we giving you homework for your own good, Until I know what I'm talking about. So you know what I'm talking about. Oh no. I'll let
yes,
teachers
sir.
don't say that. I feel like it's so hypocritical. Cause like every time my teacher say that, like in UINA, be like, damn, I really don't want to do this. So I know how it's feeling right now, but if you do it, you'll benefit from doing it. It does sound cliche, but if you want to become an ad maths legend, you had to do the practice. Alright, so all of this is homework. It looking like plenty, but I don't think it that bad. I think you all will definitely figure it out. I believe so. I think you all could do it. Some probably big homework here. Avinash is still with us.
Yes, sir. I'm alive.
I didn't really call you much because you and Serena got it correct. So no dig, no horrors. Say like I forget your hunting.
Sorry, sir. No one unforgettable.
That's good. Glad you know that. For good reasons or bad reasons?
Good reason. Sorry.
Okay, that's good. Right. So this is all your homework. Let me just take a screenshot of this and put it in the chat so you all can say, where the homework there, boy? Right, somebody take a screenshot of this and put it in the chat. Yeah, guys, take a screenshot of this. Okay, you guys have that. Somebody take a screenshot and put it in the chat for me. Somebody. One of you guys. Somebody. Did anybody take a screenshot and put it in chat for me? Anybody?
I did say.
Okay, thank you very much, Serena. Big up yourself. But yeah, guys, I hope you have a blessed night. I will see you all next week. Yeah, I'll see you guys next week. Bye bye, everybody. Take care.
It does.
It's